Okay, so we're looking at some revision despite being threatened by some students. So if I didn't do this, I was going to do it anyway. Just people who are threatening me. Okay, so we're looking at a series of questions just to give you an idea of what we're going to be looking at. Okay, so we're going to pause, have a go at the first two, and when you're ready, come back live. Okay, so in the second one, I actually forgot to give you the domain, so I'm going to do... Okay, so hopefully you did something anyway. Okay, so the first thing we're going to do is change theta to 2 theta. And then we're going to say tan is positive first, third, fifth, and seventh quadrants. So 2 theta equals, for tan being 1, we've got pi on 4. So pi on 4, 5 pi on 4. And then for 5 and 7, just add 2 pi to both those answers, which is going to be 8 pi. So it's 9 pi. And 8 is 13 pi, and then divide through by 2. Okay, so that's the first one. Next one. Don't forget, so that's what you have to do. So now we go 2 theta again, so 0, 2 theta, 4 pi, and then minus pi on 6 from both ends. Okay, 4, 6 are 24, so subtract 23 pi. Okay, on 6. So, sine is positive. First, second, fifth, 6th quadrant. Now that answer there is the minus first quadrant, but sine isn't positive there, so we can just forget about that. If that had been a cos question, we would have to think about minus pi on 6 as being a possible answer. Okay, so for sine being a half, that's going to be pi on 6. So 2 theta minus pi on 6 equals pi on 6, subtract 5 pi on 6, add 12, so that's 13 pi on 6, add 12, 17 pi on 6, and then 2 theta, add pi on 6, so that's going to be, just make it 2 pi on 6, I won't worry about dividing, 6 pi on 6, 14 pi on 6, 18 pi on 6, and then divide through by 2. So the 2 goes back to pi on 6. Okay, divide through 3 pi on 6, which will be pi on 2. Divide through is 7 pi on 6, which is okay. Divide through is 9 pi on 6, which is 3 pi on 2. Okay. So that's the answer to that. Let's move to the next square, next board. Okay, so have another go. This is one that reduces to a quadratic. When you're ready, have a go. Okay, so you're back. So I've got cos squared and sine. You can't change sine, but you can change cos squared. So sine squared equals 1 minus cos squared. So I've got 15. Oh no, I want to go the way. No, so it's cos squared. Hang on. Cos squared equals 1 minus sine squared. I want to turn it to sine squared. So 15 bracket 1 minus sine squared theta minus 7 sine theta plus 13 equals 0. Multiply through. 15 minus 15 sine squared theta minus 7 plus 13 equals 0. Take all of that to the other side to make them pluses. So I've got 15 sine squared theta plus 7 sine theta, 13, 28. 15 minus 28 equals 0. Okay, so I'm back. When I did that, I was a bit worried about the numbers, and in actual fact it can't be factorised, because if we say let A equal sine theta, So we end up with 15a squared plus 7a minus 28 equals 0. That doesn't factorise. If you look at the discriminant b squared minus 4ac, you end up with 1729, which you can't square root, which means that it's impossible to factorise. So if there was a question like that, hopefully there would be a quadratic here that you can solve. And I'm not going to change the tape because I've already started. So let's move on. Okay, so simplify fully on logs. Pause. This is a really quick one, and when you're ready, come back. Okay, so we've got 3 times log 2 4 equals 2 plus log 2 a half is minus 1. So we get 6 minus 1 equals 5. And there's other ways of doing it, but the answer is still going to be 5. Okay, solving some simple log equations. Pause when you're ready, come back live. Okay, in the first one, that's the base 2. That's the indice minus 3 equals x. So x equals 1 over 8. In this next one, that's the base x. That's the power 4 equals 81. 81 is the same as 3 to the 4, so x to the 4 equals 81. So x is just 3. Okay, come across when you're ready. Okay, next one, log equations. When you're ready, have a go. Hopefully they'll work. Okay, so next one, we've got log 2 x minus 3 plus means you multiply. Now this one here, if we're going to turn that into log 2, that'll be log 2 4. Okay, so now we've got x squared minus 3x equals 4. You can forget the logs. So x squared minus 3x minus 4 equals 0. So x minus 4, x plus 1 equals 0. So x equals 4 or negative 1. And what's x? That's it. Now, x can only equal 4 because when you look at the original question, okay, change the boards. You can't put a number to a power and get a negative answer. Like 2 to the power of 3, 2 to the power of minus 4, you can't get a negative. So this one doesn't exist. Okay, next one. Okay, so again, we've had these ones before. So let a equals 2 to the x. So then you've got a squared plus 3a minus 4 equals 0. Bracket a plus 4a minus 1 equals 0. So a equals negative 4 or positive 1. And what's a equal to? 2 to the x. Now, as I just said a second ago, that number, you can't raise a number to a power and get a negative, so that doesn't exist. So 2 to the x equals 1, so x equals 0. Okay, moving around. Okay, simple log. This is our last page. Okay, so solve these equations. Have a go when you're ready. Okay, this one here, so we take logs of both sides. Doesn't matter which base, of course. So then x log 5 equals log 2. So x equals log 2 over log 5. Get my calculator. Log 2 divided by log 5 equals 0.4307. Okay, so let's have a look at the next one. So we take logs of both sides. Log 2 to the x times 3 to the x equals log 10. Therefore, log 2 to the x plus log 3 to the x equals log 10. Therefore, x log 2 plus x log 3 equals log 10. So x bracket log 2 plus log 3 equals log 10. So x equals log 10 over log 2 plus log 3, which you need to put in brackets. And we'll have a go. So log 10 clear, log 10 divided by open bracket, log 2 plus log 3 close bracket equals 1.2851. Okay, and I think that's the end of the first tape. So there you go. Hope you enjoyed.